Okay, so Joe travels to school in 2 seconds. Stays at school for 3 seconds. Then travels to Mary's position in 1 second. Plot his motion on a position versus time graph and velocity versus time graph. So you've cut out your sheet of paper, and we're going to plot position versus time graph and velocity versus time graph. We know that time is going to be on the x-axis for both the position and velocity graphs. And so I'm going to go ahead and write those in. Position is going to be on this graph. It's going to be on the y-axis, and it's in meters. And velocity is going to be on the y-axis of this graph, and it's going to be in meters per second. And I'm going to go ahead and put my title, P versus T, V versus T. Okay? And then I'm going to go ahead and just sketch my axis. And let me put this one here, actually. Okay. So we're going to be as neat as possible. All right, so our time, we need to know how much time we have. Joe travels to school in 2 seconds, stays at school for 3 seconds, and then travels to Mary's in 1 second. That's 6 seconds. So I need to represent at least 6 seconds on my graph. Here's 0, 1, 2, 3, 4, 5, 6. Then on this one I have 0, 1, 2, 3, 4, 5, 6 seconds. Now, we know that Joe was located initially at -2 meters from previous problems. So Joe is going to start at -2, and he has to end up at 5. So if we say -2, -1, 0, 1, 2, 3, 4, 5, we have enough room. Okay? And we don't know the velocities yet, so we're going to hold off on labeling the y-axis on the velocity versus time graph. But let's plot the positions. He starts out at -2, and he goes to school in 2 seconds. School is at the origin. He stays at school for 3 seconds. At 5 seconds, he goes to Mary's, which is at 5 meters. It takes him 1 second. So that's the plots. We're going to assume that Joe's motion is constant motion or rest. And so that makes this linear. And this is the plot of his position versus time graph. Okay? Now, we've already said that the slope of a position versus time graph is the velocity. There are 3 distinct velocities represented on this graph, so we need to figure out the 3 slopes. The first one, V1, it's just equal to the change in the y divided by the change in the x. The change in the y, 0 minus a negative 2 is 2. Divided by 2 minus 0 is 2. So the velocity is 1 meter per second. The second velocity, v2, is represented by a horizontal line. We know the slope of a horizontal line is 0. So 0 meters per second is our velocity. And then the third one, we have to revert back to our equation. v3 is just the slope of this third line segment. So it's the change in the y. 5 minus 0 is 5. Divided by, let me write that out. 5 minus 0 divided by 6 minus 5 is going to be 5 meters per second. So we have 3 slopes. All right, so now we're going to graph our velocity versus time. Our initial velocity is 1 meter per second. So we're going to go 0, 1, 2, 3, 4, 5, 6. We travel at 1 meter per second for 2 seconds. Then we travel at 0 meters per second for 3 seconds. And then we travel at 5 meters per second for 1 second. And I'm going to put a pin, I'm going to mark with a different color pin just so you can see this a little bit better. And then sometimes in these graphs you're going to see dashed lines connecting the different velocities. So I'm going to go ahead and put those. And that just shows that it's a continuous motion. And that is the position versus time graphs and the velocity versus time graphs for Joe's motion.